Welcome, calculus students, and we're finishing up the area between curves. This is a mixture type of problem. Some are going to be with respect to x, some are going to be with respect to y. Couple key parts here. If it's respect to x, it will be written as y equals, and that's usually a general notation there. That's usually how you can tell which way it's written. If it's respect to y, usually they'll read it as x equals. You can obviously solve for x or y. Now, doing the first equation here, we have these two equations, e to the x and 6, e to the negative x plus 1. Now, let me go ahead and look at my picture, and this is the graph here. Oh, I just erased all the intersection points. But there's a couple ways you can do this. Now, we could do this with respect to y and look at this sideways. If it's respect to y, then we go from y value to y value to y value. We'd have to do two integrals, the red line up to 3, and then 3 to 7 for the blue line. But I just want to do one integral, but I got to figure out what's the exact value of that number. So let's go back to my whiteboard and solve this out. And by the way, if you did not see the answer there, it is this one here. It is going up and it's cut off at the y-axis. All right, so if I set these equal to each other, e to the x equals 6 e to the negative plus 1. Subtract everything over to one side, so these minus 6 e to the negative x, minus 1 equals 0. And then from that point, I'm going to multiply by e to the x through the whole equation. Now the right side is going to be nice because anything times 0 is just 0, so it'll be e to the 2x. This, since it has a negative exponent, well, if I have a negative exponent and a positive exponent, when you multiply, you're going to add them together and get 0. Anything to the 0 power is 1, so I'll be negative 6. And then the last one here is negative e to the x. Now, I'm hoping that you're looking at this and looking at it and go, wait a minute, that looks a lot like a quadratic, like that problem. In fact, it is. That's what it is there. So let me get rid of that. So if you know how to factor the quadratic, you know how to factor this problem. So what multiplies to give me 6? And that's give me negative 1. So there's my answer. Now I got to set them both equal to 0. Natural log will never equal a negative number. So if I solve this one, remember the way you get rid of an e, you do natural log. Natural log will never be a negative. So in this case, it's going to be this one, do natural log on both sides. And guess what natural log of 3 actually equals? It actually equals the 1.09. It's actually 8 after that, but it does round up. All right, so make sure you remember that number. That's important there. We're going to have to use that again. So my integral is going to be written as, since I'm doing this with respect to x, I have to go from x value to x value, 0 to natural log of 3. As you can see from my picture, it's going from the x-axis 0 up to the natural log of 3. And now whenever I just got to do top minus bottom. Well, the top is the red line, the bottom is the blue line, so it's going to be 6e to the negative x plus 1 minus e to the, that's just x there. And of course, MyMathLab wants the exact answer. So do take your time, be careful with this, you have to take. And of course, MyMathLab wants the exact answer. So we're going to have to take the antiderivative. I'm actually going to switch colors here. I'm going to go with the rainbow color here. I'm going to take the antiderivative of each one. Just do take note, it's with respect to x. And so this first expression, I almost have to do like a u substitution. So this will turn into negative 6e to the negative x plus x. And then negative e to the x. Remember, that's what's nice about e is that the derivative, why is this doing it that? The derivative in the integral is itself there. So let me try to fix this. Natural log of 3 and then 0. Plug in natural log and plug in 0. Now, take your time on this because this does get kind of messy here. Negative 6e to the negative, make sure I get this right. Yeah, it'll be negative natural log 3. And it's negative because of that negative. There's the natural log plus natural log of 3 minus e to the natural log of 3. I'm going to go ahead and simplify this. I'll come back and do the 0. This is like negative 6e to the natural log of 3 on the bottom because the negative exponent will flip it upside down, plus natural log of 3. And nice thing about this is natural log and e will cancel each other and just give you 3. Natural log and e will cancel here and actually just gives you negative 2 plus natural log of 3 minus 3. Obviously, I can write that as negative 5 and combine everything together. Now, if I plug in 0 for the rest of it, it'll be negative. Let me go back. Sorry, that's just the first half. So let me do the second half. I'm going to go back, look at the equation, taking 0, plugging into all of this. So it will end up with, I'm going to actually go back to a black here, e to the 0 plus 0 minus 0. I'm sorry, it's e to the 0. So anything to the 0 power is 1. So that's just 1 there as well. And whenever I subtract this, I get negative 7. So now whenever I combine everything back together, I know this is kind of messy, negative 5 plus natural log of 3 minus negative 7. Well, the negative and the negative are going to combine together and make a plus 7, in which the final answer is negative, let me read that again, natural log of 3 plus 2. Do take your time. There is a lot of work, a lot of details that you have to pay attention to. I did go through that kind of fairly quickly, so just be careful with this. But that's mostly the rest of the problems here. That's exactly on this one. I would graph it and then just take the antiderivative, find the graph of it. Notice how these equations say x equals, x equals. Well, since they do read x equals, I would just go ahead, oops, I didn't mean to do that. I would just go ahead, let me go all the way back up. I'm trying to go up to the notes. Oh, there. If they read x equals, then just go ahead and make it dy. Make everything with respect to y. That means everything's off the y-axis, the y constraint, the lowest y-intercept to the largest one there. Take your time. If you have questions, definitely meet up and we'll go over some of the help. Use the question help whenever it's necessary. Have a good day.